Good evening, Kritika. Good evening, Himanshu. Only two have joined. Good evening, Archika. Good evening, Archika. Okay. Till the time others are joining, can you tell me what is the source of? Uh, Good evening, Shingarika. Hello, how are you? Hello, Rani, Priyanshi. Good evening. So, till the times others are joining, can you tell me what is the source of oleic acid? What is the source of malic acid? What is the source of acetic acid? I will take the names of some acid and you have to give me their sources. Right? And then we'll start today the classification of acid based on its basicity. Okay? Am I audible? Right, fast. Okay. So the source of acidic acid is vinegar, right? And vinegar we obtain from the fruits after the fermentation. Then citric acid means all citrus fruits. Then butyric acid is from butter gone bad or rancid. Yes, derived from plants. No, the what kind of sources are these? All are organic in nature. I am taking the name of the organic acid and we are talking about their sources, right? So when we talk about acetic acid, just now I told you the source is vinegar. For citric acid, all citrus fruits like oranges and lemons. For butyric acid, butter when go rancid, right? And when butter go oxidize and becomes rancid, it start giving very bad smell. Then it produce a butyric acid. Then lactic acid, obviously lactic acid is present in the milk, right? Or curd. The when curd go to the it becomes sour in taste. Then yes, Manas, good evening. So oleic acid from olive oil, malic acid from apples, you can note down, right? Then tartaric acid from fruits such as grapes, apples, tamarind, right? What is the source of tartaric acid? Grapes, apples, tamarind, right? Then what is the source of stearic acid? Yes, ma'am, why concentrated sulfuric acid is a weak acid as compared to dilute? Because acid shows their acidic presence only on the presence of their, no, acid shows their acidic nature only in the presence of water, right? Kritika said citric acid in lemon. So in the presence of water, they ionize and they give more H plus ion in comparison to concentrated. Where the water is amount is less, so they will not ionize to up to that extent. Okay, and then tartaric acid, because dilution of acid is highly exothermic acid and they are going to produce H plus ions. More number of H plus ion can be produced after dilution. Otherwise, they are the polar covalent compound. They will not ionize. Succinic acid from vegetable oil like lettuce and unripe fruit, right? Then formic acid, we know that it is present in the stings of bees and ants. And uric acid is present in the urine, right? So we have understood about 11 acid. Those are organic acid and every day we are dealing with those acid. But generally whenever we see this kind of acid, these type of acids are the weak acid and do not ionize completely in solution, right? So we have understood that till the last classes, we'll do the recapitulation. What are acids? Acids are the substances that produce H plus ions when they are dissolved in water. Yes, Chingarika? So when they are dissolved in water, they are going to give us H plus ions. But acids in the dry form, they are not going to show any acidic behavior. And acidic behavior is because of the presence of H plus ion in the acid. Like suppose if in HCl gives H plus ion and chloride ion when they are diluted, and sulfuric acid gives 2H plus ion and sulfate ion, then nitric acid gives 1H plus ion and 1 nitrate ions, right? So bases are the oxide and metallic oxides or hydroxides of metals, and then they react and utilize the acid to form salt and water only. It means whenever they are going to combine with the acid, they are going to form salt and water. So when you see the calcium hydroxide, sodium hydroxide, these are the water soluble bases. These are the water soluble bases, and all water soluble bases are known as, alkalis, right? And I told you in acidic solution there are more H plus sign, and then the hydroxide in the last class we have discussed. In alkaline solution there are more number of hydroxide in comparison to H plus sign. Acid that dissociate, or there is a correct word for that, that is ionize to a large extent, are the strong electrolytes and strong acid, and those who are ionizing to a small extent, they are the weak acid and the weak electrolytes. Likewise, we can classify bases also. The bases who can ionize completely, they are going to give us more H plus sign. Now the today very important topic which we are going to study is the how we can classify acid on the basis of basicity of acid, and how we can classify bases on the basis of acidity of bases, right? When we say acidity or basicity, right? So what is the meaning of basicity of acid? Why we have taken this word for acids, right? So I told you, good evening Anushka. Okay, so whenever we talk about basicity of acid, right, it means the how many number of H plus ions which can be produced by per molecule of acid. It means, suppose what is common in all the acid, beta? The hydrogen is common in all the acid. Obviously when they are dissolved in water, they are going to give us H plus ions. But the all acid cannot give us the same number of H plus ion. Suppose HNO3 contain only one hydrogen ion, one hydrogen atom, so it can give us only one H plus ion. Suppose when we talk about H2SO4, since it contains two hydrogen atoms, so it can give us 2 H plus ion, right? And if you talk about phosphoric acid contains 3 hydrogen atom, it can give us 3 H plus ion, right? So whenever we talk about basicity of acid, it means what? Why this basicity word is attached to the acid? Because there is a two definition of basicity of acid. One is to how many number of H plus ion which can be produced by per molecule of acid, and the second is how many number of hydroxide ions are required with which one molecule of acid can combine to neutralize. If you want a complete neutralization reaction, suppose if one acid is giving us one H plus ion, so it is going to give us, just wait for a second, I will show you on the Krita screen. So we have understood the basicity means what? There are two definitions of basicity of acid. One is what? How many number of H plus ion which can be produced by per molecule of acid. Which can be produced by per molecule of acid. And second is, why we are talking about the number of hydroxide ion? We know that when acid combined with base, right? When acid combined with base, they are going to give us salt and water, right? So how? Because when you take, for example, let's take a simple example. Suppose if we are taking HCl, right, and HCl is diluted, right, and if it is going to combine with sodium hydroxide. So when one molecule of HCl is going to combine with one molecule of sodium hydroxide, there will be complete neutralization reaction. Why? Because when you see this HCl is going to give us one H plus ion, and I told you the acid shows their acidic behavior only in the presence of water. So in case of HCl, it is going, since one hydrogen atom is there, so it is going to give us one H plus ion. So if you want to neutralize the one molecule of acid, you require one hydroxide. In this case, since it is giving us one H plus ion, So you require one hydroxide ion in order to neutralize one molecule of hydrochloric acid, right? So we can see it is going to give us one hydroxide ion when you take the sodium hydroxide. So we can say that one H plus ion and one hydroxide ion both will combine together to form water. It means this, there is no hydrogen ions are left behind which are not combined with sodium hydroxide, or there is no hydroxide. It means there will be complete neutralization reaction. So during this cat, what is left behind? We can see there is an N plus ion, Na plus and Cl minus is left. So this H plus ions and hydroxide ion both are combined to give us water, and water is neutral and we get salt and water. So we can see if it is going to produce one H plus ion, if we want to neutralize the one molecule acid, so we require one hydroxide ion. So we can say the number of hydroxide ion with which one molecule of acid is going to combine, that will be equal to its basicity. Since it requires one hydroxide ion, so its basicity will be 1. So all monobasic acid. So on the basis of this, we can classify acid into 3 categories. One is monobasic acid, second is dibasic acid, and third is tribasic acid. We can see all monobasic acids are going to give us 1 H plus ion. Like in this case, we can see it is going to give us 1 H plus ion and 1 Cl minus when they are ionized. In this case, it is going to give me HNO3 or once again, since one at hydrogen atom, so it is going to give us 1 H plus ion and nitrate ion. Once again, it require what? It require one hydroxide. It also require one hydroxide ion. Okay. So in this case also we will get only one H plus ion. The rest will be acetate ion, right? So this will be, this is a weak acid, right? This is acetate ion, CH3COO minus. Once again, it can give only one H plus ion, so it is a monobasic acid. So all monobasic acids are going to give us only one H plus ion, and they require one hydroxide ion in order to neutralize the one molecule of an acid. And that's why we say this word basicity of acid, because it requires hydroxide ion in order to neutralize itself. So we say it is a basicity of acid. So what is a basicity? Where you find only one H plus ion is going to produce, obviously the basicity will be equal to 1. And they can form only normal salt, right? They can form only normal salt. Why they can form only? Just now I have shown you that it is going to form, because they are going to completely neutralize, so they are going to form only normal salts. So monobasic acids are going to form normal salt. Normal salt means neutral salt, right? So HCl is going to give us 1 H plus ion. HNO3 is also going to give us a 1 H plus ion. Acetic acid also, it is since it is a weak acid, it is not going to completely ionize, so it is going to give us only 1. In this case, formic acid is also going to give us only 1 H plus ion, and the formate ion will be produced. So we can see in all cases we are getting only 1 H plus ion, and if you want to neutralize the one molecule of acid, you require only one hydroxide ion, right? So this is known as its basicity. Okay, so on the basis of how many number of H plus ion can be produced by per molecule, or how many number of hydroxide ions are required in order to neutralize one molecule of acid, we can classify acid into 3 categories. One is monobasic acid, where 1 H plus ion and 1 hydroxide ion requirement is there. Then dibasic acids, it means they are going to produce 2 H plus ions. So we can see in case of H2SO4, in case of H2SO4, so we can see how many H plus ions are going to produce. So 2 H plus ions, right? So we can see 2 H plus ions, since there are 2. So carbonic acid will also give us 2 H plus ion. Since they are going to produce 2 H plus ions, so they are going to form what type of acid? These two are dibasic acid, because they are going to give us 2 H plus ions. So that's why it is dibasic acid, and they require 2 hydroxide ion for complete neutralization of per molecule. Understood or not understood? Yes, Dikshant, Anushka, Shingarika, understood or not understood? Please write in the chat box. Please write in the chat box. Yes, bacha? Okay. So we can see dibasic acids are going to produce 2H plus ions and they require 2 hydroxide in order to neutralize the one molecule of acid, because one molecule of acids are going to produce 2H plus ions and they require 2 hydroxide in order to become neutralized. Suppose we are taking H2SO4, clear, and we are taking NaOH, right? In that case we will not get a complete neutralization reaction. Why? Because in this case we can see it is going to give us 2H plus ion. It means if you want to neutralize one molecule of sulfuric acid, you require 2 hydroxide ion. But in this case, it is going to give us only one hydroxide ion. So no complete neutralization reaction is going to take place. In that case, we will get a acid salt. Acid salt. So NaHSO4, because one hydrogen cannot be replaced. So we still have one unreplaceable hydrogen atom with us. So we are not going to get a normal salt in case of dibasic. But for that we need to take base in the excess quantity. So we can prepare two kind of salt with this. One is the acid salt, another is normal salt when base will be taken in excess quantity. So once again we'll get the salt and water, but still the salt will become what kind of salt? Acid salt will be formed. So if you want to neutralize one molecule of this sulfuric acid, you require base in excess quantity. For example, if you take H2SO4 plus 2 NaOH, now it can give us, now we can make, if we have taken base in the excess quantity, in that case we can get. So once again we'll take aqueous sulfuric acid and aqueous sodium hydroxide, but this time we have taken sodium hydroxide in excess. So now we will get Na2SO4, which is a normal salt, plus H2O. So this is Na2SO4 plus H2O. It means it is normal. So we can say that with the help of dibasic acid, we can prepare two types of salt. One is the normal salt, where we need to take base in excess quantity, or second, if we are taking sulfuric acid and a less quantity of base is taken, in that case we can get acid salt. So if we are not getting 2 hydroxide ion, so we can get acid salt. If we are getting this normal, how we can get the normal salt? Obviously we have to take, if it is a monoacidic base, because sodium hydroxide is monoacidic base, because it is going to give us one hydroxide ion, it require only one H plus ion in order to neutralize the one molecule of base, right? So in that case, once again we can see with the help of dibasic acid we can make two kind of salt. One is acidic, another is normal. And acidic means when we have taken the less quantity sodium hydroxide to acidic salt. If we have taken an excess, then we'll get normal salt. Then one more thing I would like to highlight here, whenever we see, you can see in the previous case when HCl was taken, HCl is what? Mono, it is a monobasic acid. Then I told you CH3COOH is also what? This is also what? Just wait for a second. Okay, so when these are diluted, when these are diluted, they are going to give us only one H plus ion, right? And you can see, since they have only one hydrogen atom, they are going to give us only one H plus ion, so they will dissociate into one step. They can dissociate only in the one step. In this case also we can see one H plus ion in acetic acid and formate acetate ion will be formed. In case of HNO3, one H plus ion, and we can always write H plus AQ. Why we need to write H plus AQ? Because we know that H plus ions are unstable. They will combine with the one water molecule. So they are going to form hydronium ion. Okay, understood? So in that case, a nitrate ion will be formed. we can see they are dissociating into one step. But whenever we take a dibasic acids, okay, so for example H2SO4, so they are going to dissociate into two steps, right? In the first step, when they are diluted, what is going to happen? They are going to give us one hydronium ion, right, plus HSO4 1 minus hydrogen sulfate, because still we can see one hydrogen atom is there, right, which has not converted into H plus ion. So once again we'll dilute HSO4 1 minus plus H2O. It is going to give one more hydronium ion. Right now, this time we'll get sulfate 2 minus. So it means when dibasic acids are diluted, they ionize into two steps, and that's why these two are diporotic acid. So those who are dissociating into one step, or they are ionizing into one step, then monoporotic acid. If it is a dibasic acid, obviously it is going to ionize into two steps. So it is a diporotic acid. So dibasic acids are diporotic. Why? Because they are going to, now we can see this will cancel, right? So what we are going to get? We are going to get H2SO4, right, plus 2H2O. It is going to give us 2 hydronium ion plus sulfate, right? It means in how many steps? This is the first step and this is second step. It means H2SO4 is going to ionize into two steps. It means it is a diporotic acid. So I told you dibasic acids are going to form two kind of, they are going to give us 2H plus ion, and in order to neutralize one dibasic acid, we require 2 hydroxide ion. So its basicity is 2. For dibasic acid, basicity will be 2 because they require 2 hydroxide ion in order to neutralize one molecule of acid. And the third thing, which is very important, I told you they can form acid salt as well as normal salt. And just now we have discussed they can dissociate into two steps. Now when you take a tribasic acid, for example H3 PO4, right, it is a tribasic acid. Obviously when they are going to dissolve in water, so they are going to dissolve in water, they are going to give us 3H plus ion because 3 hydrogen atoms are present. Since 3 hydrogen atoms are present, so they are going to give us 3 H plus ion, and the phosphoric acid is going to dissociate, or you can say ionize, into 3 steps. We can see in sulfuric acid, since 2 hydrogen atoms were there, so they have the sulfuric acid dissociated into 2 steps. In this case there are 3 hydrogen atoms, so they are going to dissociate into 3 steps. So now if you want to neutralize one molecule of phosphoric acid, you require 3 hydroxide ions. You require 3 hydroxide ion. Understood? So in that case we can see how it is going to change into, obviously in the first step one hydronium ion will be produced and dihydrogen phosphate will be formed. Then H2PO4 2 minus plus H2O. So it is going to give us one more hydronium ion plus HPO4, right? So HPO 1 minus, then once again we'll take this HPO4 1 minus plus H2O. So it is going to give us one more because one hydrogen atom is left. So one more hydronium ion can be produced, and PO4, sorry, it is 1, this is 2 minus, and then PO4 3 minus. Understood? So now we can see all together how many, so this got cancelled. Okay, so this will got cancelled, this will also got cancelled with this and this. Okay, so we can write collectively now. So when H3PO4 is diluted with 3 water molecule, it is going to give us 3 hydronium ion and 1 phosphate ion will be produced. Clear? Clear everyone? So it is a diporotic acid. Now we can see It can form two acidic salt and one normal salt, right? So it can form two types of acidic salt and one normal salt. So we can see from here. So suppose if we are taking H3PO4, right, and we have taken NaOH, so obviously it is going to give us monosodium, that is a monosodium dihydrogen phosphate. Okay, so monosodium dihydrogen phosphate, so PO4. Understood? So if you are taking H3PO4, now obviously this is acidic salt because there are two hydrogen atom which are not replaced. Okay, so it is an acidic salt. So monosodium dihydrogen phosphate is acidic salt. Once again, now if we take little bit more quantity, so 2 NaOH, and then we will get Na2HPO4 plus 2H2O. Once again, this is what? This is disodium hydrogen phosphate. This is also, once again, we can see hydrogen is present here. So it is also a acid salt. So we can see, but if you take H3PO4 plus 3NaOH. Yes, Anushka. Anushka, are you there? So we can see when you take 3 NaOH, so what is going to happen? We will get Na3PO4. Now this is the normal salt, right? Understood, Anushka? Shingarika? Anushka, Shingarika, Dikshant, Kritika. Okay, so Na3PO4 plus 3H2O. Understood? So obviously this is the normal salt, this is acid salt, this is also acid salts. How many of you have understood? Understood? Okay, so let's go back to presentation. Now we can easily understand. Yes. Okay, good. Anushka, good. Wonderful. So we can easily understand what is the meaning of basicity of acid, the number of hydrogen ions which can be produced by one molecule of an acid, right? Or how many number of hydroxide ions are required with which one molecule of acid is going to combine, or in other words, we can say that, which what could be the other definition, right? Because it require hydroxide, and that's why we have given this basicity word, right? Likewise, in case of bases, you can see it is written acidity. It means if you want to neutralize base, they require H plus ion, but if you want to neutralize acid, they require hydroxide ion, and that's why this word was attached, basicity of acid. Okay, so we can classify acid on the basis of basicity. If they are going to give us one H plus ion, or they require one hydroxide ion in order to neutralize one molecule of acid, they are known as monobasic acids, and their basicity will be 1. Okay, and they can form only one kind of salt, that is a normal salt, right? Then if you see dibasic acids, if you see dibasic acid, it means they are going to dissociate into two steps. They are going to form 2H plus ion per molecule of acid, or they require two hydroxide ion in order to replace two hydrogen atom. So they require two hydroxide ion in order to neutralize one molecule of acid, right? And they are going to produce 2H plus ion. They can form two types of salt. One is acid salt, when the base is, if it is a monoacidic base, if they are combining with a monoacidic base which can produce only one hydroxide ion, in that case they are going to form acid salt, because we can see the replacement hydrogen atom will be there. And then if you take base and acid, then that time they are going to form, normal salt. So what could be the example? Sulfurous acid, once again contain two hydrogen atoms. Sulfurous acid is going to give us 2H plus ion. Sulfuric acid, just now we have discussed, sulfuric acid also contain two hydrogen atom. They will give us 2H plus ion, and they require sulfuric acid require 2 hydroxide ion in order to neutralize 1 molecule of sulfuric acid. Likewise, carbonic acid is the formula is H2CO3. It is going to give us 2H plus ion. It requires 2 hydroxide ion in order to neutralize 1 molecule of carbonic acid. Likewise, so their basicity will be 2 because they are going to give us 2. Then once I have discussed with you, they are going to dissociate into 2 steps. That's why they are diporotic acid. Then the third one is tribasic acids. Obviously, from tri we can understand they are going to give us 3H plus ion, and they require 3 hydroxide ion in order to neutralize 1 molecule of acid, and they are going to dissociate into 3 steps, or you can say ionize into 3 steps. Okay, and then they can form 2 types of salts, or sorry, 2 types of acid salts, and one will be the normal. It means 3 kind of salts they can form, 2 acidic and 1 normal. Likewise, we can classify bases also. Like we have discussed basicity of acid, likewise we can discuss about acidity of base. Like we know that neutralization reaction will take place only when, so how we can get, just wait for a second, let me pick up pen. We know that neutralization reaction can take place. Suppose this is NaOH and it require 1 HCl. Why one molecule of HCl? Because then in that case it is going to give us 1 hydroxide ion, right? And this HCl is going to give us 1 H plus ion. It means we can neutralize the per molecule of a base, right? So it means it is a monoacidic base. Why? Because acidity of base means the number of hydroxide ions which can be produced by per molecule. If it is going to produce 1 molecule, obviously monoacidic base. If some are going to produce 2 hydroxide ion per molecule, they are diacidic base. If they are going to produce 3 hydroxide ion per molecule, like aluminium hydroxide or ferric hydroxide or chromic hydroxide, they are going to give us 3 hydroxide ion. So they are what? Actually, they require 3 H plus ions. Okay. So in that case, we can see the NaOH is a monoacidic base. Why? Because it is going to give us 1 hydroxide ion, right? And it can dissociate into 1 step only, because there is no chance. So we can see that NaOH, when it is diluted, it is going to give us Na plus and OH minus. Easy. So we can easily see it is going to give us Na plus OH minus. And obviously, if you want to neutralize 1 molecule of sodium hydroxide, you require 1 H plus ion. So its acidity will be 1. What will be the acidity of monoacidic base? Obviously 1, because it requires 1 H plus ion. So HCl can give all monobasic acids can neutralize monoacidic base completely. All monobasic acids can neutralize monoacidic base completely. Why? Because monoacidic base require 1 H plus ion, and monobasic acids are going to give us 1 H plus ion. So complete neutralization reaction are going to take place. It means they are going to form normal salt. They are going to form normal salt. Understood, class? Okay, now we can see that NaOH, okay, we can see NaOH is example, KOH is example, ammonium hydroxide is example, because all are going to give us 1 lithium hydroxide, all are going to give us 1 hydroxide ion per molecule. So those who are having a 1 hydroxide ion per molecule, obviously they require 1 H plus ion. So that's why they are monoacidic base. I hope everybody has understood. So what is the acidity of base? The number of hydroxide ions produced by per molecule of a base. Then how many number of H plus ions are? How many number of? Yes, it's monobasic. You are saying monobasic, Anushka, for what? You are talking about base or acid? Okay, so we can see they require how many number of, obviously the number of H plus sign, which should be equal to number of hydrox, then only the complete neutralization reaction is going to take place. Suppose we are taking calcium hydroxide. Let me clear this if I can. Okay, so we can clear this. Just wait for a second. Okay, so in this reaction we can say, oh my god. Okay, so in this reaction what we can see, the second, when you see the calcium hydroxide, right? So when you see the calcium hydroxide is obviously it is going to give us two hydroxide. Okay, so it is going to give us two hydroxides. Why? Because it requires CaOH whole twice. Per molecule is going to give us two hydroxide. For example, copper hydroxide is also going to give us, magnesium hydroxide is also going to give us two hydroxide. So it is a diacidic base. Copper hydroxide, magnesium hydroxide, zinc hydroxide, all are going to give us, barium hydroxide. There are so many examples which can be taken as example for diacidic base, because then they will ionize in the aqueous solution. They are going to produce two hydroxide or two hydroxyl per molecule of the base, and two they require 2H plus ion in order to neutralize one molecule of base. Suppose if we are taking magnesium hydroxide ion, we are taking magnesium hydroxide and you require 2 HCl. Why you require 2 HCl? Because we can see it is going to produce 2 hydroxide ion, and 2 HCl can give us 2 H plus ion. Then in that case, so complete neutralization reaction is going to take place. But on the other hand, if you take magnesium hydroxide plus HCl, if you are taking diacidic base and monobasic acid, in that case, obviously we are going to get basic salt, because one hydroxide ion cannot be replaced, because it is going to give us only one H plus ion. But if you want to if you want a complete neutralization of this, so you require 2 H plus ion. So if you take acid in excess quantity, then only this reaction can take place, where complete neutralization reaction is going to take place. But in this case, if you are taking diacidic base and you are taking monobasic acid, so the what will be the salt? Salt will be, it will be basic magnesium chloride plus H2O. It is going to form basic magnesium chloride. So it means one hydroxide is not replaced. So it requires 2 H plus ion, then only the complete neutralization reaction is going to take place. I hope everybody has understood. Everybody has understood. Then next is tri tri acidic base. Now they ionizes to produce obviously 3 hydroxide ions per molecule of the base, and they require 3 H plus ion if you want to neutralize one molecule of triacidic base. Understood, Anushka? So in that case, for example, this is aluminium hydroxide. So it is going to give us, let's go back to screen. Just wait. Okay, so let's check up the examples, right? So just now we have seen NaOH. When they are in an aqueous form, they are going to give us Na plus and OH minus. Suppose we are taking CaOH whole twice, and if they are in the aqueous form, they are going to give us Ca2 plus and 2 hydroxide. Then if you are taking aluminium hydroxide, right? And if they are diluted, they are going to give us 3 hydroxidine, aluminium 3 plus and 3 hydroxidine. So on the basis of requirement, we can say it is a monoacidic base because it requires 1 H plus sign. It required 2 H plus sign because it is going to give us 2 hydroxidine. And if you want to neutralize the one molecule of base, you require 2 H plus sign. So it is a diacidic base. It is a triacidic base because it is going to produce 3 hydroxidines. Understood? Since it is going to produce 3 hydroxidines, so it requires 3 H plus sign if you want to neutralize the one molecule of acid. Okay, so they can form basic salt also, right? And they can form normal salt also. Understood? So I hope this is clear with everyone. So let's go back. Let's understand. So we can see the basicity of a acid is what? It is the number of ionizable H plus ion present in an acid. How many number of H plus ion can be ionized from the per molecule? So HCl is a monobasic because it ionizes to produce one H plus ion. Understood? Right? So we can see HCl is a monobasic because it is going to give us 1 H plus ion. H2SO4 is a dibasic because it ionizes to produce 2 H plus ion. Right? And phosphoric acid is a tribasic acid because it ionizes to produce 3 H plus ion. Likewise, we can understand for the acidity of base also, it is an ionizable hydroxidine present in an alkali because if they are going to produce one hydroxidine, they are monoacidic base. If they are going to produce 3 hydroxidine, dry acidic base. If they are going to produce 3 hydroxidine, so triacidic base. For 2, diacidic. For 3, triacidic. Understood? Okay. Now how we can prepare acid? We have understood the classification, one more classification. Then how we can prepare the acids, right? So let's discuss how we can prepare. We will write the reaction in order to understand. So we'll go back. Okay, so let's discuss. Now, the first method says, as per the first method, we can prepare acids from the non-metals because we know what is common in all the acid. Hydrogen is common in all the acid. When hydrogen combined with the non-metal, hydroacid can be produced, right? If you remember, we have done the classification based on what? These are the binary acid because two elements are there. One hydrogen will be the obviously one atom will be hydrogen, another will be non-metal. So these are also known as halogen acids. Why? Because hydrogen is going to combine with one of the halogen, right? So we can see if acids can be prepared with the help of, direct combination reaction of hydrogen with non-metal. For example, if hydrogen is going to combine with this 2HCl, so hydrochloric acid will be produced. Initially it will be in a gaseous state, but when they are diluted, it can convert, hydrogen fluoride can convert into hydrochloric acid. Likewise, hydroiodic acid can be produced. Hydrobromic acid can be produced, that is HBr. So 2HBr. So we can see with the direct combination reaction from hydrogen with the non-metal, we can produce these acids, right? So we can also produce acids from the acidic oxides. We know that non-metallic oxides are acidic in nature. When they combine with the water, they are going to produce like, for example, if we are taking CO2, it means we can write here non-metallic oxide plus water. They are going to form their respective acids, right? Obviously they are going to produce acid. Suppose if we are taking carbon dioxide, obviously we get a carbonic acid, that is H2CO3, right? If you are taking if you are taking sulfur dioxide and adding water in that, you will get sulfurous acid, that is H2SO3. if you are taking sulfur trioxide plus water, you will get sulfuric acid, that is H2SO4. Understood? If you are taking phosphorus pentaoxide, or you will get phosphoric acid, that is 2H3PO4. Understood? So, and if you are taking NO2 plus H2O, you can get a mixture of acid. If you remember in the class 9, we have studied HNO2 or HNO3, nitrous acid and nitric acid. Understood? So, we get a mixture of nitric acid, we get a mixture of nitric acid and nitrous acid. Okay, so we can prepare acid from the acidic oxide. When acidic oxides are dissolved in water, they are going to form the respective acid. When carbon dioxide combined with water, carbonic acid. When sulfur dioxide combined with water, sulfurous acid. When sulfur trioxide combined with water, it is going to form sulfuric acid. When phosphorus pentoxide going to combine with water, phosphoric acid. And nitrogen dioxide is going to give us mixture of two acid, nitrous acid and nitric acid. We can also prepare acid with the help of when acid is going to combine with the salt. So we can see the salt one, right? This is salt 1 and this is acid 1, right? When it is going to combine with each other, they are going to form different salt and different acids, right? Now we can see in this case, initially it is a non-volatile acid. Sulfuric acid is a non-volatile acid. We can prepare volatile acid from non-volatile acid. The same question is being asked in the board examination. So we can get what type of salt? Obviously in this case we are going to get, because it is KHSO4, we will get acidic salt plus HNO3 will be formed, HNO3, right? So it means nitric acid is a volatile acid, but sulfuric acid is non-volatile acid. When you heat potassium nitrate in the less than 200 temperature, we can get one more acid, that is a nitric acid. So we can prepare acids from the acids, the reaction of acid with the salt. Likewise, if you take sodium chloride and it is a sulfuric acid, now new acid is depend on the which anion is present in the salt. Here nitrate ion, so nitric acid, since it is Cl minus, so obviously hydrochloric acid can be produced. So we can get NaH. Once again, when you heat sodium chloride in the less than 200 degree temperature, we will get acid salt, that is sodium hydrogen sulfate plus HCl gas will be formed. Once again, it is a volatile acid. Okay, so once again, it is a volatile acid. Okay, understood, class? Okay. Now one more thing, we can prepare acid by oxidation of the non-metal. It is the last topic which we are going to discuss. So whenever non-metals are combined with the oxidizing agent, like we can see the nitric acid is a strong oxidizing agent. Nitric acid is a strong oxidizing agent. So non-metal, for example, sulfur is oxidized by concentrated nitric acid to give an acid, that is H2SO4. We can prepare H2SO4 with the help of this. So H2SO4 plus 2 H2O plus 6 NO2. This is the balanced chemical equation. We can see from sulfur, when sulfur combined with the oxidizing agent, that is the nitric acid, and what is the condition of this? It should be concentrated nitric acid. Okay, so we can get sulfuric acid. So it is a sulfuric acid. So by oxidizing non-metal, right, with the help of oxidizing agents, so we can get another acid. How many of you have understood? Okay, so I hope everybody has understood this. Okay, so in the next class we'll learn about the preparation method of the bases. Okay, so thank you very much. God bless you all. I hope everybody has understood this concept. In the next class, we are going to start the chemical properties and then we'll start salts also. Thank you. God bless you. Thank you, Anushka. Thank you.